Let us see about impulse response and LTI system. Impulse response: when the input to a discrete time system is a unit impulse del of n, then the output is called the impulse response of the system and is denoted by h of n. It is given by del of n. It is in the transfer function. It is given by h of n. And the properties of parallel connections of discrete time system. While we are seeing this, it is otherwise said to be distributive property. Here we are connecting this two system h1 of 2 and h1 of n and h2 of n are connected together together. They are connected parallelly and they are given to the summer. Finally we are getting the output as hy of n equal to h1 of n plus h2 of n. Just this is h of n equal to h1 of n, convolution h of n, h2 of n. Let us see the problem. Determine the frequency response and impulse response of y of n minus 1 by 6 y of n minus 1 minus 1 by 6 y of n minus 2 equal to x of n. Now we find the discrete time Fourier transform. While we are taking the discrete time Fourier transform, after finding this we are just grouping and we are forming the frequency response. That is h of e power j omega equal to y of e power j omega by x of e power j omega, which is given by this equation, and then we are applying the partial fraction expansion to find out the values. Finally we are finding the value for a and b, and finally we are grouping it into two terms, and then we are applying the inverse discrete Fourier transform. Therefore we are getting the value of h of n as list like this. Next one is LTI system analysis using discrete time Fourier transform. Let us give this by the linear convolution, that is y of n equal to summation of h of n into x of n minus k. Let the sinusoidal phasor can be given as x of n equal to e power j omega n. While we are substituting this in this equation, therefore we are getting this equation like this: y of n equal to summation of h of k into e power j omega n minus k. And here we are subdividing that exponential term and grouping the term. Therefore we can write this as h of omega in e power j omega n, where h of omega equals summation of h of k into e power j omega n, and here h of k can be written in terms of magnitude and phase. And the LTI system analysis is a transform. Here the transfer function, it is given as y of z equal to x of z into h of z. Therefore the general form of transfer function is given like this. Now we are applying the inverse as a transform in this equation. Therefore here y of n minus k can be written as z power minus k into y of z. After writing this, we are just computing the z transform as h of z equal to summation of bk into z power minus k divided by summation of ak into z power minus k. Thank you.